In this video, I'm going to introduce to you guys how you can write polynomial functions given a few zeros of that polynomial. So what I just did, as you can see, I have a screenshot of a problem that's very similar to the one that you'll have to do, where it says you have to write the polynomial function of least degree with integral coefficients that has the given zeros. Number one most important thing is whenever you're given the zeros, you have to remember that the factors of the polynomial are always of the form x minus whatever the zero is. So if you can remember, this is like the setup. I mean, ultimately, that's the one thing to remember, and it becomes pretty easy. So if I have a 0 of 2, my first factor is going to be x minus that number 2. The second factor is going to be x minus 4. And my third factor is going to be x minus this 0, negative 2. Now, there is a double negative because I'm doing always x minus whatever the 0 happens to be. So that's a common mistake students make, is they forget that double negative. So what I'm going to be careful to do here, as soon as I have a minus, I like to make a big plus. So again, if you have that double negative, make sure to turn that into a plus. That's basically it for the setup. Unfortunately, you cannot leave your function written like that in factored form. We want to multiply everything out and write the polynomial in standard form. So it just becomes an exercise in multiplication. By the way, what I'm going to do is, because I see these two factors are like conjugate pairs, one's x minus 2 and one's x plus 2, I'm going to start by foiling x minus 2 times x plus 2. That's a little bit easier than multiplying x minus 2 and x minus 4 first. So I'm going to try to make my life easier by first just foiling those out. If I do x times x, there's my x squared. Then I'm going to have plus 2x, and then a minus 2x, and then negative 2 times positive 2 is negative 4. So these guys right here cancel out. 2x minus 2x cancel, and I get just x squared minus 4. Now I still have to multiply that to another x minus 4. So I have a little bit more foiling to do. Let me see if I can squeeze that in over here. So if I foil that out, if I do x squared times x, that's x cubed. If I do x squared times negative 4, there's negative 4x squareds. And then if I do negative 4 times x, that's minus 4x. And I'm going to do negative 4 times negative 4, that is positive 16. Now if I could, I would add like terms, but none of these are like terms, so I'm finished. I have in standard form the polynomial is x cubed minus 4x squared minus 4x plus 16. Okay, I'm going to do another example where it gets a little bit trickier. Now I'm giving you a polynomial function that you have to write of least degree that's got integral coefficients and has the following zeros. Now these zeros are a little bit trickier because they're irrational numbers. The thing you have to remember here is irrational zeros. So if you have square roots, they come in conjugate pairs. So what that means is I wouldn't have only one 0 that's at 2 square root 2. It would have to have a complex conjugate pair in an irrational pair, negative 2 rad 2. And then the same thing goes for the square root of 10. It wouldn't be just the square root of 10. You have to know that there'd be another 0 at the negative square root of 10. So really I have 4 zeros here in all to set up my factors. So the way I would set this up is the same as before. My factors are always of the form x minus the 0. So if I start with this first 0, it would be x minus 2 rad 2. That's my first factor. And then the next factor would be x minus, let's do the conjugate pair of that guy, negative 2 rad 2. So I'm going to do x minus negative 2 rad 2. Minus minus becomes a big old plus, so really that factor is x plus 2 rad 2. The next factor is going to be x minus this guy, the square root of 10. And then the next factor would be x minus this 0 at negative square root of 10. So there's a double negative. It's minus a negative square root of 10, which is really a big old plus. So how I would multiply this out, because it does look a little scary, I will admit, I would focus on multiplying together those conjugate pairs, because things cancel out really nicely. So check this out. It cleans up pretty well. If I do x times x, that is x squared. Then I'm going to have a plus 2 rad 2x. So plus 2 rad 2x. Then there's going to be a minus 2 rad 2x. And if you'll notice, these are identical. 2 square root of 2x minus 2 square root of 2x. Those wipe out beautifully. Then I just have to do negative 2 rad 2 times positive 2 rad 2. And this is where students get a little confused. So I'm going to kind of focus on this down here. So if I do negative 2 square root of 2 times positive 2 square root of 2, right? If I'm multiplying these numbers together, I think the trick to remember is multiply the numbers together. So like I'm going to multiply the negative 2 times the positive 2, and that's negative 4. Now I'm going to multiply square root of 2 times square root of 2. Now you have to remember, square root of 2 times the square root of 2 is nice. That's just the number 2. So this really is negative 4 times the number 2. That is negative 8 as a result. So I'm going to write this as x squared minus 8. So that turns out to be x squared minus 8. Really, that factor after I multiply it out. If I do these guys, I'd get x times x. There's my x squared. And then what happens with these terms is I get the positive square root of 10x. And then the inner terms would be minus the square root of 10x. So those cancel. And then negative square root of 10 times positive square root of 10 is just negative. Remember, root 10 times root 10 would just be 10. So that factor turns into just x squared minus 10. So my next step is to FOIL these guys out. And I'm going to do that. Let me erase this a little bit. Hopefully you already have that written down. So if I do that, x squared times x squared is x to the 4th. Then I have negative 10x squared minus 8x squared. And then negative 8 times negative 10 is positive 80. So I have x to the 4th. These guys are negative 18x squareds. And then plus 80. And I am finished. That is my function written in standard form. It's supposed to be an equal sign, but I'm having a heck of a time. Sorry about that. So f of x is x to the 4th. That's supposed to be positive x to the 4th here. Jeez. So x to the 4th minus 18x squared plus 80 is my final answer there. The final example I'm going to do with you guys gives you some zeros that are imaginary. And just like when you get zeros that are irrational, the thing you have to remember is that imaginary zeros also come in complex conjugate pairs. So you wouldn't have just one 3i. It would have to have its complex conjugate negative 3i. And you wouldn't have just one negative 2i. Its complex conjugate pair would be positive 2i. So those are all of the zeros. So when I write the factors for this one, I'm going to do x minus 3i. And if I do its conjugate x minus negative 3i, that really turns into a positive 3i. And then the other zeros give me the factors of x minus, if I choose that zero, it would be minus negative 2i, which is really a big old plus 2i, right? And then the final factor is going to be x minus 2i. And again, to make your life easier, what I would suggest doing is definitely multiply together the complex conjugate pairs first. So if I do that, I get x times x, x squared. And you might guess what's going to happen with 3i times x and negative 3i times x. They would cancel. So I'm not even going to bother writing them down, just like the last example. If I do negative 3i times positive 3i, that's going to be negative 9i squared. Now recall, I squared is really the number negative 1. So this is x squared minus 9 times negative 1. So it's really x squared plus 9 as my factor after I FOIL it. Now if I focus on these two guys, x times x is my x squared, then minus 2ix plus 2ix cancel, and if I multiply 2I times negative 2I, that's going to be minus 4I squared. Remember, I squared is negative 1, so this is really x squared minus 4 times negative 1, or x squared plus 4. So I still need to multiply these together. I have to do x squared plus 9 times x squared plus 4. So if we multiply that together, x squared times x squared, I'm going to write the result down at the bottom here as x to the 4th. X squared times 4 is positive 4x squared. Then I'm going to have a plus 9x squareds plus 36. So at the end of the day, my function f of x is x to the 4th plus, now these are like terms, 4 plus 9 is 13x squareds plus 36, and I'm finito. Thanks for watching, guys. I hope this helped.